Hello, good morning, everybody. Just to make everybody aware that there are some PDFs to download to go with the webinar today. If you go down to the chat box, it's going to be on the very top. Um, there are 4 PDFs you can download. If you don't download them this morning, you'll be able to download them when I send out an email after this meeting. We should start in a few minutes, so thank you for joining us. We'll be with you guys in a moment. If you're looking for the downloads for the PDFs, if you hit the chat option and you scroll all the way to the top, you'll see there are 4 PDFs to download. Again, you'll hit the chat or conversation button, scroll all the way to the top, and you'll see 4 PDFs to download. All right. Good morning, everybody. We'll give it another 2 minutes, give everybody an option to log on and get their stuff ready. I was told that many of you can't see the PDFs to download. I'll be pushing those to you guys in a moment. Just hang tight. Thank you for being patient with us. Frank, are you on with us? I see you're on.
Yes, I am. Can you hear me?
Yes, I can. Awesome. Thank you.
Yep, no problem.
All right, it's 10:03. Let's get started. I want to say good morning, everybody. Thank you for joining us today. Um, today you're going to learn a lot about future of networks regarding on PoE and Wi-Fi. Today's webinar will last about an hour. There are handouts to download. I will push those to you momentarily. Today's presenter is Frank Straka. He is a product line manager at Panduit. He oversees the whole entire copper line. So today's information, you're getting it from the person. A little bit about Frank. Frank has a Master's of Engineering from Syracuse University and received his bachelor's from the University of Notre Dame. He has been with Panduit for over 15 years. He started his career there as a research and product development engineer. He worked on RJ45, jacks, plugs, cables, basically everything we deal with on a daily basis. He worked up the ranks to become product development manager, worked on category 6, and then in June of 2016, he became the product line manager. So again, you're getting this source from the man himself, who you deal with this on a daily basis. Before we begin, please hit the mute button. Don't want to interrupt anybody. If you need to take a call or need to walk away, this webinar is being recorded, so I will push that to you after the meeting. If you have any questions, we'll have about 5 minutes Q&A after this webinar. If not, you can reach out to your sales reps here at Arrow, and they'll be more than happy to answer any questions you have. And with that, Frank, the floor is yours.
All right. Thank you very much. And thank you, everyone, for spending the time to come here and listen to me talk about these wonderful topics here. So can everyone see my slides right now?
Yeah, the slides are up.
Fantastic. All right. So really, here today to talk about some of the biggest drivers, in the industry right now. And I mean, as we know, there's, COVID put a big hit. Most of the models we're seeing and things, are expected to kind of, 2021 is going to almost look like 2020 just didn't happen, right? Where things are going to bounce back towards closer to the 2019 levels. I think there's a lot of people talking too about, what does the future of the office look like? The one comment I tell a lot of people on that is, from my standpoint, if I hear one of our competitors just decided to go fully remote, I welcome my competition doing that because, from our standpoint, returning to the office, I think the offices could be different. I think people have more flexibility, but there's a lot of studies out there that say the importance of, face-to-face interaction and whatnot is more important than ever. So, with that, I'm here today to talk about some of the things then that, within these offices and with these commercial buildings are going to be really, driving the future and driving people's decision on structured cabling. And that is Wi-Fi and power over Ethernet are two of the big factors. And one thing I like to start with and just kind of level set with people on is that when you start talking about, wireless and wired, and some people, it's like, is it wired versus wireless? Is it, what's going on with it? It's not always one versus the other, right? Sometimes wired has a lot of good features, and sometimes a strong wired network is really there to complement and even provide better performance for that wireless one. And this is just a fun fact I'd like to throw up here because, some people look at something simple like a sensor deployment and say, well, I deployed some sensors or I did this and that. And, I did it all wirelessly. It works great. I don't understand why I would ever want to wire up. And this example here just is, maybe like a building of the future, right? Where it's, maybe it's a large warehouse or, manufacturing site. And the person really just wanted to make this just a fantastic, building of the future. IoT, throws a lot of sensors around or all these other devices. And, he ends up putting 10,000 wireless devices in the facility. And if you assume a 5-year battery life, which is pretty standard on batteries for these things, I'll say it probably won't last much more than 5 years. You're going to have 2,000 batteries fails per year. Now, if you assume there's 200 working days per year, 10 batteries need to be replaced each day. If you assume 20 to 30 minutes per battery, It's about 4 to 5 hours per day, or about half a person to replace batteries. Another quote I've heard out of a gentleman at Cisco that I've spent some time with is he says that if you ever want 30% of your devices to not be working at any given time, go wireless. An example I like to give on it too is that we have a security system that we threw in our home, or that came with our house. One day, my wife and I decided to just try to figure it out and activate it. We call a guy. He convinces us to put in some wireless sensors, and told, oh yeah, these batteries will last 5-10 years. I'm pretty sure within the first year we had some failures, and let me tell you about these failures. They like to occur in the middle of the night when I was out of town traveling. And then I wake up in the morning with some angry text messages from my wife saying, the damn system started beeping. I didn't know what was wrong with it. Turns out a battery went dead. Because battery life can be dependent on a lot of stuff like heat and other factors. So the point with all this is just the fact that, wired in a lot of cases can be best practice, not just from, a Panduit perspective, but just because of the fact that, when you run something there that's wired, it's effectively permanent, right? You don't have to worry about batteries. The elements of our security system, the old system we had, that was wired, and we've never had a problem with it. And I think a lot of people are going to find that as, a lot of these things are coming out, these sensors and everything else, having that wired infrastructure is critical for people to really go about and, have a reliable facility with things that won't fail. Here's the agenda. I'm going to talk a little about wired versus wireless. I'm going to talk a lot about power over Ethernet, which is an underlying technology that's enabling a lot of this. Talk about where Wi-Fi is going, and then give some of the cabling recommendations with it. And so the first topic, wired versus wireless, and my comment on it is there's nothing wireless about wireless. So simple example here on one of the advantages of wired versus wireless is it's shared versus dedicated bandwidth. I mean, it really matters in these circumstances where, depending on how reliable of a connection you might want to have. I know for myself, I now work from home. I've been working from home for 5 months, and hopefully I don't have any hiccups in this presentation. But I can tell you that if I could run a wired connection to my computer right now, I would definitely do it. I've had lots of random issues throughout the day where all of a sudden, Teams disconnects from me or something else happens. Maybe my kids are all, watching YouTube downstairs, or, someone's watching Netflix. So there's a lot of conflicts you have between, the shared versus dedicated, right? So, you just see that simple example here, right? You got 3 laptops sharing one 10G base T signal versus each one has their own dedicated line. And those dedicated lines are also less susceptible to things like interference or, things bouncing off. We use a mesh network in our house, and I can tell you that is not the most reliable network to always use. The other example here is power delivery comparison. Is that, you look at this simple example here, is that if you were running each one of these phones off of a wireless signal, you still need to run power to them, right? And so you imagine this scenario is that you've got 3 power lines, and that you have one cable going to the access point. Let's assume it's PoE. So you've actually got, really 4 runs of wires for the wireless system versus you'd only have 3 runs with power over Ethernet. So it's just a quick example here that you might actually be running less wires with a wired setup than with a wireless system when you include the power elements to it. So it's just a different way to think of it that a lot of people don't always consider. Going back to categories, I think for the 2020 standpoint, I could put a red arrow by a lot of these right now, but I think as we're finally getting towards the second half of the year here, things are starting to look a little bit more up. But the arrows up there on top are very directional. I'm sure you guys at Arrow are seeing the same things, whereas Cat 5e is down. Cat 6 has stayed relatively flat. I'd say, depending on, the month or whatever, you could see it a little up or down. But Category 6A has been growing like crazy for us here at Panduit. It's been a very successful product. And you can see just some of the drivers that really are the reasons people are putting in 6A. Is 6A really offers, optimal support of power over Ethernet. If anyone's ever heard, me talk, or other people at Panduit talk, or with Ewing Foley. The Cat 6A cables, when you bundle them all together, they can get a little hotter, and Category 6A helps dissipate that heat much better. The other one is that Category 6A was designed for 10G base T. So while the other categories, you say you can do a little bit over it over Cat 6, that's really not recommended. If you read the 10G base T standard, it was really designed to be run over a Category 6A cable. So those are really the two factors, in my view, that are driving people to put in Category 6A. Another thing that we've looked at Panduit, and I think you guys will have access to some of these white papers. They're available on panduit.com, but I think we have sent them over, is that wired and wireless working together. So again, another example on this is it's not just wired, versus wireless, but really coming to think of it as, maybe you want the best of both worlds here. And, the consideration to make, and what I'm trying to say here is that a robust wireless network is almost like a business requirement, right? Back when I could, go places like restaurants or, malls and whatnot, I actually would have some idea, especially when I walked into the place, you'd be like, oh yeah, this is the place where I can't get a signal, right? Or wow, this is the place where it has a really good Wi-Fi network. And you're sitting there maybe at dinner and still looking at some work emails, looking up, maybe a score or something like that. But in your mind, you kind of know where do you get good Wi-Fi and where you don't. Or even think of an office, right? You might have a section of the building that doesn't get as good a performance on your Wi-Fi. And if you're sitting there trying to download files off the network or do something else, that can be a real detriment. So ideally, you really, really want to have a good, robust wireless network. And with that, you can also imagine that in an area like an office, when I sit down at my desk, say I'm, in a conference room, I'm on the Wi-Fi. Then I, go to another conference room on the Wi-Fi. But then I sit down at my desk, my wonderful laptop, I've been gone 2 hours and it's already at like 10% charge or something like that. I need to plug it in to charge it. When you plug it in, data and power. And by doing that, by just that act of plugging, I now am off the wireless network and I'm on the wired network. And so what advantage does that convey? And we had some of our people in R&D take a look at that. This was just imagine you had an access point with people at different distances, right? So, the people that are closest are going to get the best performance. People that are furthest will get the worst. That's just how wireless works. And assuming that, there's 36 people, each person has 2 devices. So maybe a laptop and a cell phone. And then we have the performance criteria here is that actual bandwidth available divided by required bandwidth. So basically saying that, if you need 100 megabits, you can get 100 megabits, right, or more. And you want that criteria greater than 1. Came up with some different type of user profiles, high end, middle, low end. So, the high end was pretty demanding. We looked at that. We created some test cases where we looked at a variety of scenarios, number of clients split between 3 wireless access points. And we kind of did something like this, right? Where we basically were looking at what was your performance ratio and how many clients were then served by those access points, okay? So basically here, all the way on the left, I'd be saying that none of the clients were on the wired network. They were all on the wireless. And as I go over here to the right, that I'm being served entirely by the wired network. So obviously that's not realistic either. You want to be somewhere in the middle. And this here is probably 2 simultaneous clients. So that's basically what are the chances that 2 people are going to be asking for something at the same time. So ideally what you want to see is that this probability goes down and your performance ratio goes up as you're putting more and more people on the wired network. So really what we're trying to see is how well does your overall network perform, right, when you're basically combining a wired and wireless network and you're offloading some percentage of that wireless network onto the wired network. And this was just the summary that we found here. So this graph all the way over here, hoping you guys can see my mouse, with like this light blue at the bottom, you can see here that you can serve up to about, 70, maybe say it's 75 clients with the performance ratio greater than 1. And then if you jump all the way over to the yellow line is 25% of all clients are offloaded onto the wired network. You could actually get up to 96. And then with 33, you're at 108. So a simple way to think of this, right, is just by taking a few people and moving them off the wireless network onto the wired. And that could be as simple as, when I go back to my desk, I plug in my laptop, right, to charge it, and that puts me off the wireless network. Or that could be as simple as, hey, that engineer over there, he's got a desktop computer and he's doing some really, intense modeling. He's going to get his own even dedicated connection, and we're just going to assume he's never on the wireless network. He's always going to be wired. Just by doing that, you get a much more robust wireless network, right? This network here, if you're already at 72 clients today, you can barely expand it, but if you're taking a third of the people and putting them onto the wireless network, you have room for expansion. You could add more people into that area, right? You could assume that, maybe all of a sudden Apple comes up with this really cool new other technology you've never thought you needed until now. And now people are bringing in those devices, and now you've got, more and more people on the wireless network, but in short, it can handle it, right? Because it's got that extra capacity from that wired system. So just a brief summary, right? There are many environments that support both wired and wireless networks. Offloading to wired can improve a wireless network by over 25%. These wired networks better future-proof these wireless networks, and a robust wired network will be a very nice complement to a wireless one. Now moving on, power over Ethernet, critical technology. And power over Ethernet, planning this webinar, we really want to talk about the future of networks. It's almost impossible to talk about the future of networks without really considering something like power over Ethernet. The key here is the new standard. Here, power over Ethernet plus plus, or PoE plus plus, also called 4-pair PoE 4E. And it's the most AT type 2, which delivers up to about 25.5 watts. When the new Cisco standard, we heard of Cisco's UPoE. Cisco's UPoE is now one of these new standards. Here, there's this 50 or the 60 watts, delivering 51 watts to the end device. And then there's the highest power one that's providing of 10 Gbps. So this new standard is very exciting to all of us in cabling, right? You're providing a lot more power to end devices, and there's a lot more stuff that could run over our structured cabling systems that we provide. And it's, roughly, my numbers down there, it's a 2x increase in pair. Before you were going from, running only over 2 of the 4 pairs, now it's all 4. It's about a 50% increase in current. You're going from 600 milliamps up to about an amp, and that's giving you about a 3x. This just shows you PoE usage by application type. This was from PoE Applications Global Trends by Bizria. And I'm guessing, when we see this revised forecast, 2020 graph will be down a little bit, but then it's expected to grow back up. And you can just see, right? In 2019, they estimated about 117 million PoE ports shipped. And they expect these PoE ports to increase by 11 to 12.8% annually. That's huge. And then on this here, right, where this is just showing, by application, how many of these are the percentage of the overall PoE ports being used. So you can see voice over IP phones, about a third of all PoE ports are going to them. Wireless access points, about 23% of PoE ports are going to them. And then this one down here, right, sensors, that's only 7%. So very small percentage right now are running to sensors. That's a huge opportunity here because as we expect more and more sensors to be deployed and to grow, that's a big opportunity. But again, very bullish on, PoE port shipments. And some of the surveys we've been looking at, because, we're, like anybody, we're interested to understand what impact COVID's going to have on everything, really does show that they expect a lot of this stuff to really bounce back and, to be healthy. And, it's in all likelihood will accelerate, some types of these developments because, when you talk to people about what's the building of the future look like, it's going to be smarter. So you can do more tracking and understand where people are going to be. There's going to be likely updates to, areas like HVAC to make it, more efficient and healthier. And in all honesty, too, people are kind of expecting offices to become almost friendlier places, right? Rather than it being somewhere you have to go, it's going to be somewhere that you want to go. And smart buildings are going to enable all that, and really smart buildings run by PoE. I won't dwell on this, just really say that there's a lot of standards governing PoE, whether it's from the IEEE that writes the more of the application, provides some, I'll say, loose cabling guidance, all the way down to TIA that take that loose cabling guidance and make it into detailed specifications on cable. One of the important standards to talk here is TSB 184A. This refers to heat rise in different bundle sizes. And really what it looks like is, I think I briefly mentioned it, when you bundle all the cables together, they get hotter. And then you run the current on them and you put a thermocouple in the middle of that cable and you see how hot the center of it gets. And really what you're looking for in all this is that you want to make sure that the center of the cable stays below 15 degrees above ambient. It's kind of a recommendation provided by it. And what this shows here is just different cables, heat rise with different bundle sizes. You can see that, Cat 5e, it gets pretty hot, over 20 degrees at a 100 cable bundle. A typical 6/8 cable gets to right about 15. And then this one down here is a Panduit 6/8 cable that uses our matrix foil, if anyone's familiar. It's like a metallic tape that goes around the outside. And by having that metallic tape there, metal, it's a good conductor, right? You touch a frying pan, it burns you because metal is a good conductor. So having that metal foil there really helps dissipate the heat out. This used to be newer information. I'm assuming that, people might be familiar with this one. I know Ewing Foley's done a good job of, making people aware of this, out the impact of it. But the 2017 National Electric Code did have an impact on power over Ethernet. And what it does is it recognizes a new UL listing for limited power cables, and does, by having that listing imposes some requirements onto building installations. And so this UL listing for limited power LP cables is not required, but you'll see why it's kind of recommended. But you need at least a 0.5 amp rating. And you might say, what's a 0.5 amp? Because didn't you just tell me that this new PoE standard is going to about 1 amp? So the NEC looks at current per wire, whereas traditionally in PoE and structured cabling, we've referred to it as current per pair. Right, so you have 1 amp divided by 2, that's a 0.5 amp. That's where that 0.5 amp rating comes. This here, this type CMP-LP, blah, 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 this is just what's printed on the cable jacket. And this is after you've gone through the UL testing. So this means type CMP is plenum dash limited power, 0.5 amp rating, tested by UL. It's a 23 gauge cable that has a 90C operating temperature rating. LP simplifies installation and inspection. With no LP, you must be referred to the ampacity table. And the one thing to really understand with this too is just showing this graph here tries to show you where the new requirements really hit. And the NEC applies to everything, but it's really just at this highest power level that the NEC, the new requirements are really relevant. So just something to keep in mind. So now I refer to the ampacity table. This is what the ampacity table looks like. And it's really not that hard to understand once you've gotten used to it. What it basically says is for a given wire gauge, for a given cable temperature rating of 60, 75, or 90, And then for different given bundle, then you can figure out what your bundle size is. So I gave 2 examples here. So Cat5e, a typical Cat5e cable might be a 24 gauge with a 60C rating. Come over here, that's 1/2 amp. You see, it needs to be at least a 1/2 amp. You go up, you can have a bundle, at least 30, up to 61. Typical Cat 6A, it's 23 gauge, 75C rating. You can go all the way to 192. But again, right, the challenge with the ampacity is how do you inspect bundle size? Don't know. It's a challenge, right? Easy way to do it is, part of the reason people put in plenum these days is, once you just says, hey, this is plenum, you're good to go. With limited power, Panduit strategy is our Cat 6A cables will have LP as standard. Cat 6 cables we offer with a special part number, so you just put LP at the end. I still think that this is not totally aware. I'd say if you're a Panduit customer, people are getting more and more aware of this. Still, I don't get asked that many questions, from local authorities or people on it, so it does seem to be not totally aware. This graph here just shows the National Electric Code adoption by state, and you can see some people already on 2020. But say out in California, you guys have adopted the 2017, so now this is becoming it is technically an issue, but it kind of has to roll out to local areas. People sometimes ask, well, given that you don't know what's going to be run on PoE, right? You don't really know how PoE is going to be used because anything can really go on that cable. It's going to be kind of dependent on the switch and what it's connected to. So one of my speculations is that this is going to be driven by application area. So say, who might be pushing back against this? It's more on the electrician side. What are things they're concerned about is lighting. So you might see some questions and pushback on the, say you're running this to a ceiling, you might see the ceiling needs an LP cable. It's speculation on my part, but it makes some sense. This is just what the Panduit LP cable offering. Connectivity and next generation PoE. So just something to be aware of too. Power over Ethernet does impact connectivity. And what you see here in this picture is the picture on the left is what a jack looks like when it's fully engaged with the plugs. This is a Panduit jack and a Panduit plug, and I've just removed the housing so you can see it. You can see when it's fully engaged, right? The contacts are bent down and you get contact at this green area there, right? Then when I go to unplug it, now imagine PoE is running, right? It's a live circuit, it's delivering power. When I pull it out, you get a little arc. And you can sometimes see this. If you have a dark room and you, turn off the lights and just want to see what happens, you can sometimes see that little arcing. And that arcing occurs at this red location. You get these char marks there. And jacks need to be designed to meet it. So with Panduit jacks, right, our arcing occurs at a different location from where the data transmission occurs, right? When the plug gets plugged in, we're doing it at, the green point, not the red point where it occurs. We also have, we call it scraping, where from the point that you make engagement at this red point all the way to the green point, you're scraping, and that action effectively is cleaning the contacts. And so, this is, like anything, there's a standard around it. We actually have a third party that even validates that our jacks can handle power over Ethernet. So with this latest standard, so it's kind of a nice thing to have. And just the standard that says it is 60512-99-002. So if there's any questions, can a jack handle PoE++? It's not just a question of can the vendor say it, but you can also say, hey, do you guys meet this specific standard, because that is the standard that governs build up and how the plug and jack can handle it. So summary of PoE. The new standards provides up to 71 watts. The cables get hotter. LP rating is something people should really consider for cables to be in compliance with the 2017 code. and ensure that your connectivity meets the IEC 60512-99-002 to ensure that your jack can handle the higher power levels. So, Wi-Fi today and tomorrow. So just to understand where Wi-Fi is now and where we see it in the future. So wireless standards overview. In the past, we used to refer a lot of these standards by their IEEE name. So, you heard about 802.11n, 802.11ac. These are now being changed to Wi-Fi 4, Wi-Fi 5, Wi-Fi 6, and then there's 6E. And then, something that's eventually coming down the pipe is this 802.11be. We speculate that will be Wi-Fi 7, but it is yet to be certified. And really, what are these things is that, more devices than ever before, and these wireless standards are increasing at rates faster than wired. So Wi-Fi now and into the future. This is just looking at, the different bands and the different data rates that each are requiring. And I say megabits per second now. Those M's should be changed to a G. Those should be gigabits per second. And what you see on this is that as the Wi-Fi is increasing, right, as you're going up, now we're, Wi-Fi 6, you're going from using only a 5 gigahertz band to 2.4 and 5. There's this Wi-Fi 6E that will also look at using the 6 gigahertz band. Wi-Fi 7 uses all 3 bands. The density of APs, you can get the APs, the access points closer together. Once you get to Wi-Fi 7, it's going to need more than 10 gig going to it. And the cabling recommendations is really category 6A. And why is it category 6A? It's because it needs that 10G base T running to it. Because you see, as soon as you get above, Wi-Fi 4, you might have data needs greater than 1 gig, right? You're up at 6.9. So Wi-Fi 6 to allow increased densities. We need 2 cables for data and Wi-Fi 7, right? Because we're above 10 gigabits per second. To support increased densities and speeds. And we'll talk about that a little at the end of the presentation.
Hey, Frank, sorry to interrupt. Your audio is getting very choppy at times.
Oh, that's my wonderful wireless network here. Let me trying to think of what I can do. Am I coming in okay right now?
Yes, you are.
Trying to think if there's something I can do that would be quick on this. You want to do this? Maybe interrupt me if it happens again, and then because the only thing I know that internally at Panduit, I can sometimes hop on my phone to join the call, but in this case, I'm presenting, and the only thing I know that fixes it is can be sometimes a hard reset, but then I'm gonna, it takes about 5 minutes or so to come back. So if it gets bad again, let me know, and I'll do the hard reset. So.
Okay. Cool. Thank you.
Yeah, something with Microsoft Teams. I did not have this problem on our old system. Wi-Fi now and into the future. So this just shows the growth by these different access points. So again, this forecast was done before the wonderful world we live in today of COVID. But you can see that really 2020 was forecast. You're going to start seeing some of this AX here, this 6 and 6E stuff, getting wider deployments. And then really by 2021, expecting, about 50% of all Wi-Fi deployments to be, Wi-Fi 6. And then by 2022, it's really the dominant type of Wi-Fi. And there's a lot of reasons why people will like Wi-Fi 6 over Wi-Fi 5. And one of the reasons why is end device data rates and, improved speeds up to 4x. They use something called OFDMA and beamforming and improved modulation, increased capacity. So there's just more data they can fit over a given chunk, improve performance in environments with many devices. So again, there's beamforming, utilization of a band that they had stopped using in Wi-Fi 5. This can really help with IoT devices. This is a feature everyone's going to like, is improved battery life for end devices. And this is a technology that's been deployed, I know, a lot in a lot of devices to improve battery life. Where basically, it's weird to think, but with some of these chips, you're literally turning them off, turning them on, turning them off, turning them on, turning them off, turning them on. And that's essentially what's happening here with Wi-Fi 6. Is this target wake time is basically the device is going to sleep, it's waking up, it's going to sleep, it's waking up, and it's trying to just reduce that power consumption. So I mean, anyone that's ever had an iPhone die on them, this is a great thing. And then reducing latency. And so with latency, that's really how long it takes, when you click on something to when it actually happens. So once you're going, it's not as noticeable. When you click on something, it's, how long does it take for that, it to go? And so 1 millisecond, I mean, people aren't going to really notice that. One of the neat technologies in it, I'm just going to give a brief description of some of these things here. We don't need to be complete experts in it. We're just, looking at the cable side. But this is one of the biggest changes they made with Wi-Fi 6, and just illustrating it by pallets on a truck. So in the old Wi-Fi 5 standard, what they would do is they would basically divide everybody up into chunks of time. And this was all not noticeable because this was happening faster than we could perceive it. But, maybe person A got chunk 1, person B got chunk 2, then 3, right? But what happened is that not everyone used all the data in that chunk of time, right? Maybe, you're, clicking on loading a website, right? And use a little bit of it, the website loads, and then, it goes to idle, right? So you have all this wasted space where information's not being used, versus maybe there's another guy that's trying to download or watch a Netflix movie in 4K. So you can see what Wi-Fi 6 did was are totally filled. It's really dividing it up amongst each person. And you're in this example here, right? You're utilizing 96% versus 52% of space. So this really improves throughput while reducing latency. Another thing that's being used is this spatial streaming concept, and this increases the data rate by number of streams utilized. And what you can see here is that you have an input that's being split amongst 4 radios. So imagine you see an access point and it has, usually like those little black antennas that stream down, right? And what you're trying to do here is the blue radio only wants to talk to that blue radio, right? The orange radio wants to talk to that orange radio. The dark gray one only wants to go to that dark gray one. And the problem is that when you're doing this transmission, because it's electromagnetics, it's, you're trying to be targeted, but all the antennas receive all the noise, right? And what they need to do then is figure out how to differentiate the noise amongst each other. And so that's something that this Wi-Fi standards can do, and Wi-Fi 6 has gotten better at it, where you can just see now, this noise that's going from, say, antenna 1 to all the other antennas, radio 1, this top one, can now pick it up and decode it. There's another thing called beamforming. And this is a pretty neat one where beamforming shapes the radiation patterns towards client devices. So if anyone's ever heard the term omnidirectional, like an omnidirectional antenna, maybe you all haven't. I've heard the term with, my background with engineering. But basically an omnidirectional antenna is, you're transmitting noise and it goes every which way. Imagine it's like a globe where it's just radiating outwards from the globe. With beamforming, you're trying to actually shape that pulse to only go where it's needed. So rather than it radiating out in every direction, I'm actually only sending that pulse towards where I'm trying to communicate to. And that's a big difference here. And that's an important characteristic because, shaping that pulse has a lot of nice features to it, right? I might be able to get a stronger signal to where I want it to, but then I'm also not transmitting where I don't want to transmit to. And it means there's a less likelihood that you're going to pick up, noise from, say, neighboring wireless access points. If you have too many access points in a building, or they're too close, they're operating on the same frequencies, you can get something called contention. And by using beamforming, you reduce the risks of contention. Wi-Fi 7 expectations. This is currently being worked on. I will say that my one observation is, I go to the TIA standards at Panduit, and I will say standards work has been affected by COVID. Every standards meeting, anyone that's worth anything, it's all face to face. And with this, right, we spend all day for 2 days in a row looking at documents. But what it also enables you to do is you can talk to people on the sidebar because maybe there's some hot topics or things you want to resolve, and it's easier to resolve those when you're there in person, where you can maybe at coffee break or something go up and talk to somebody. But standards work has slowed. This is everyone wants Wi-Fi 7, but nothing's moving as fast as it once was. But anyway, this new standard is referred to as extremely high throughput EHP. I was expecting to use that same 6 gigahertz bandwidth. There's going to be some improvements with coordinated OFDMA, coordinated null steering, distributed MIMO to enhance beamforming. A lot of neat stuff, but really the key here, this is a stated objective within the 802.11 BE task force, is they're going to want 2 category 6A cables per access point. This is just to support the needed data rates. And it makes a lot of sense because sometimes people say, well, what about fiber? What about this? What about that? And whenever someone deploys a new standard, they want to use something that's already there, right? As a cable guy, I would always love them to install new cables, but as the equipment guy, you want them to use the existing cables to run what's already up there. And so, if anyone's familiar with the N-based-T technologies where, they're running 2.5 and 5 gig over, existing, Cat 6 cables. This is just similar in that vein, right? Where people want it to work over cables that are already installed. And so that's why the recommendation here is 2 category 6A cables per access points to support the total bandwidth needs of Wi-Fi 7. So, summary, Wi-Fi 6 is expected to be the largest and fastest growing Wi-Fi standard. It offers increased speeds, capacity, battery life, and reduced latency. So really, everything's good about it. It can offer improved access points densities, and Wi-Fi 7 is going to be just something, even neater. So, Wi-Fi cabling infrastructure recommendations. Right, so if you take a step back, the recommendation we want to say is design a cable plan for Wi-Fi 6 and beyond. You want to be able to accommodate obviously what you're going to need today and what you're going to want to need in the future, because with all these things with Wi-Fi, it's moving quicker than the cabling standards and the wired standards. You want to have something that can handle PoE. And you really just want it to be future-proof and maximize the ROI from your investment. I think I mentioned it earlier, but the observations, right? Wi-Fi 6 today needs about 10 gigabits per second. Wi-Fi 6 and beyond will have the ability to allow increased densities of access points. And future technology like Wi-Fi 7 are projected to exceed 10 gigabits per second. So that's why this recommendation of 4 6/8 cables per access point today to accommodate what you might need in the future. And I can just walk through that example. So this is just a simple, way to understand why we're saying 4 cables per access point. Is imagine today you've got 2 access points. You're running 4 cables to each access point, but you're really only using one of them. So you're only using 3 out of the 4 cables. Say tomorrow you do some restructuring, some moves around, and then people are bringing in more devices, or you found out there's areas of the building that are harder to get into. So you say, you know what, this Wi-Fi standard, it's pretty nice. It allows better densities. I'm going to put in more access points here just to, get better performance out of, for my users. So rather than having to run new cables, you just pull over the cables that are up in the ceiling. And now, you're running basically 2 cables per access point, and you're using one of those cables per access point. So you're using 2 out of the 4 cables you initially installed. And finally, you go to day 3, Wi-Fi 7's out. Everyone wants the latest and greatest, and it's got a lot of cool things to it. And so now you're just taking those cables and you're running them to each access point individually. And now you're using every cable you installed. So why do it this way? Oh, got these flipped around. Anyway, the assumption is that, so imagine that I have options 1, 2, and 3 reversed on each other, and they should be looking the other way. So running all cables today, right? Say the walls are down, everything else, it's the cheapest. Your cost there is 4x. Versus if you try to do, say, 1 cable today, 1 cable on day 2, and 2 cables on day 3, my assumption is that the cost to run cables when the walls are up, it's about 10x the cost. So, really, and the reason I'm giving examples is as soon as I tell anyone the cost of installing a cable is, the cost is to install a cable is anything, someone will say, well, that's not what I pay. So I just said it's roughly, the cost to install is X. The cost to run a cable when the walls are up and you have to, come in on overtime, pull out the old cables or pull in new cables, it's about 10 times more. So that's why you're basically comparing a cost of putting all the cables in today of 4x versus doing those cables at a later time could be up to 31x, right? So you're paying almost 10 times more to put in the same number of cables if you're going to do it at a later time. I need to update those slides. So summary of Wi-Fi cabling recommendations. Run 4 cables on day 1, and you're going to use one of them. On day 2, you're increasing the density, and now you're going to use 2 of the 4. And on day 3, all 4 out of 4 cables. And running 4 cables today provides the lowest cost and simplest upgrading. And so just some examples of the Panduit Wi-Fi solutions. We have the best Category 6A solution out in the market today, with our Verimatrix cable, and we actually launched the Verimatrix HD cable as of a few days ago, actually. So that's a very neat cable. It's actually a 230 Category 6 23 gauge cable, so really a small diameter cable. So excited about that. And then at Panduit too, we're just very focused. I call it application focused innovation. And you can see here is our field term plugs. Great for use on access points. Rather than having to say, run a cable near an access point, install a surface mount box, take a patch cord from that surface mount box and run it over to the access points and finding some way to mount it. You can just take that cable you're using, up there, run it right by the access point, terminate a plug on it and plug it in. Works great. It's standards compliant to do that. And you don't have to worry about, hiding the things, and, you're doing this all with less components. So Panduit does a great job on these application-focused innovations. So in wrapping up, wired connections offer a higher bandwidth and power over a single connection, right? So you're getting more speed and power over wired. Wireless struggles with the speeds and certainly cannot provide power, at least today, and well into the future. The new Wi-Fi standards offer significant improvements in speed, latency, and battery life. Basically everything people care about when they're trying to access the internet. We see Wi-Fi, will coexist with something like 5G, and usage will increase. This joint wired and wireless network optimizes and future-proofs a wireless network, and we recommend installing 4 Category 6A cables per access point. So with that, I'll open it up to people. Hope you enjoyed this presentation. Hope you learned something. And, with that, I'll just ask if there's any questions.
Thank you so much for the presentation, Frank. Earlier, if you have questions and you want to answer them, but ask them by phone, go ahead and hit *6, and the system will unmute you. But there was a question in the chat box. I believe they asked a question when you were talking about cable bundling. The question: should we be using Cat6a shielded or non-shielded?
So we would always recommend using unshielded cables as much as possible. We find that the 10G-based standards are always designed around both unshielded and shielded, and people are much more accustomed to installing shielded products or unshielded products, and there can be issues with shielded systems if they're not properly grounded and installed. So our typical recommendation would always be to install unshielded whenever possible. The only exceptions to that would be if you are in areas, say, with a lot of noise, so maybe it's like a plant floor type of environment where there's a lot of motors and just stuff going on. In those cases, we would recommend then putting in a shielded system. So certainly, like if you go on the mice tables, like the E2, E3 type environments would be much better for with shielded, whereas E1, which is the vast majority of installations, such as commercial buildings, in unshielded is fine, and you don't run into any of the potential issues like ground loops. So
thank you. Anybody else have any questions? I don't see any in the chat box either. So if there's no more questions, we'll go ahead and wrap up the webinar today. Frank, thank you so much for joining us and taking your time to present to us the features of the network. We really appreciate it. For those people who attended, you will receive a copy of the meeting in about an hour or so. And I'm sorry the handouts did not load as properly as I expected them, so I'll be emailing those out to you in a few minutes. If you don't have any more questions, Frank, everybody, thank you so much for your time. Have a great day.
Thank you. Have a great day.
Thank you, guys.
Thank you.